So to continue, our P is now our new equilibrium condition, or new price equilibrium. I'm sorry, I got this term. So the price equilibrium now is 4.18. That's the new price equilibrium. The old price equilibrium is 3.54. So obviously there is now an increase in price equilibrium from 3.54 to 4.18. Thus, because of the increase in demand, price equilibrium increased. But how much is the increase in price equilibrium? If we want to solve for the increase or the change in price equilibrium, the change in price equilibrium is simply just PE sub 2 minus PE sub 1. The new price equilibrium minus the original price equilibrium equals to the change in price equilibrium. So 4.18 minus 3.54 is now the change in price equilibrium, and probably you can already have it computed, okay, to equal to how much? 0.64, more or less equal to 0.64 pesos is the increase in price, or the change in price. Okay, so that is how we can explain how the price equilibrium happened to increase because of the increase in demand. Let us now move to the next slide, and in this next slide we have this problem statement. In fact, we use the same problem. What we are just showing is emphasizing on the effect of the increase in demand to quantity equilibrium. As we have stated, increase in demand causes an increase in quantity equilibrium. So dealing with the same problem, they're just the same problem. So we'll continue from specifying the value of quantity equilibrium original and quantity equilibrium new. So how to solve for the original quantity equilibrium? Of course, we have to equate, or rather we use either the demand or the supply equation as our reference equation. So in this particular case, we use the demand equation, so that the original demand equation is stated by QD sub 1 equal to 72.5 minus 12.5 P. Now, if we will substitute the original price equilibrium to the P of the original demand equation, what we can derive is the quantity equilibrium original. So by substituting the original price equilibrium of 3.54 to the P of the original demand equation, we can now have the quantity equilibrium original of 28.25 units. So that is QE now is equal to 72.5 minus 12.5 times 3.54. Simplifying, we can arrive at this value of 28.25 units. So what about the new equilibrium, new quantity equilibrium? So since we are making use of the demand equation, so specifically the new demand equation is to be used. So the new demand equation is given by 90 minus 12.5 P. And substituting the new price equilibrium which we have earlier solved. The new price equilibrium is 4.18. And substituting this to the price of the new demand equation, we now have 90 minus 12.5 P times 4.18 will become 90 minus 52.25, and eventually we can arrive at the new quantity equilibrium, which is 37.75 units. So again, the price equilibrium, the original and the price equilibrium should have first to be solved before you can solve for the original quantity equilibrium and new quantity equilibrium. I did not anymore illustrate much on, or rather explain much on the graph, because this is the same graph in the previous slide. Let us focus on the other slide. Okay, let me okay, so this new slide is not different from the earlier slide that I have presented. Okay, so this is just the summary. So to sum up, okay, increase in demand causes an increase in quantity equilibrium, while increase in demand causes an increase in price equilibrium. That is to say, change in demand and change in equilibrium condition are directly related. So let us have here another case. This time we will illustrate what would happen to the equilibrium condition if there will be, or rather if a decrease in demand exists. So notice that in our graph we have the demand curve shifted to the left, while there is no shift in the supply curve, meaning to say that the supply is constant and there is a decrease in demand. Now, let us refer to the problem statement. The original demand and supply equations are given by QD equal to 72.5 minus 12.9 P and QS is equal to minus 25 plus 15 P respectively. Solve for the new price and quantity equilibrium given that a decrease in demand by 22.5 units occurred after a period of time. So in the problem statement, there is a decrease in demand by 22.5 units. So what we have to do first is to specify our original demand equation. So our original demand equation is QD sub 1 equals to 72.5 minus 12.5 P. Now, what about the new demand equation, or QD sub 2? We can derive the QD sub 2 by adding the change in demand from the original demand equation, or QD sub 1. So QD sub 1 plus the change in demand will give us the QD sub 2, which is the new demand equation. So since the change in demand is decreased by 22.5, so the change in demand is negative 22.5. So QD sub 1 minus 22.5 is therefore equivalent to our QD sub 2. So that QD sub 2 is now equal to 72.5 minus 12.5p minus 22.5, and the derived new demand equation, or QD sub 2, is now equal to 50 minus 12.5p. So there it is. In our curve, we have this original demand curve given by the equation QD sub 1 is equal to 72.5 minus 12.5p, and we have our new demand curve given by the equation QD sub 2 equals to 50 minus 12.5p. So the demand curve shifted to the left, referring to decrease in demand. And because of the shift of the demand curve to the left, there is now a change in equilibrium point, okay, which refers to our change in equilibrium. So there is that original equilibrium point between QD1 and QS1, and a new equilibrium point between QD2 and QS2. Now, since there is no change in supply, QS sub 1 is equal to QS sub 2. And if we are now to solve for the original price equilibrium, we now have to equate QS sub 1 to QD sub 1. And so we have negative 25 plus 15p equals 72.5 minus 12.5p. Bringing all those terms with p to the left side of the equality sign, we have 15p plus 12.5p. And bringing all those whole number to the right side of the equality sign, so that we have 72.5 plus 25. The plus 25 is actually originally the negative 25 found to the left side of the equality side. And because of transposition, it becomes positive. So we now have the sum of 27.5p by adding 15p plus 12.5p. And we now have the sum of 97.5 in our whole numbers, adding 72.5 plus 25. So that 27.5p is equal to 97.5. And solving for phi, we can now transpose the coefficient of p to the other side so that it can become a divisor. And p now is equal to 97.5 divided by 27.5. And the quotient is equal to 3.54. And this is our original price equilibrium. So what about the new price equilibrium? The new price equilibrium is between QS2 and QD2. And to equate QS2 to QD2, we have negative 25 plus 15p equals to 50 minus 12.5p. And again, by simplifying, we can arrive at the p-value of 2.73. And the 2.73 is the new price equilibrium. So we have the original price equilibrium, and we now have the new price equilibrium. And we can use this original and new price equilibrium by solving the original quantity equilibrium and new quantity equilibrium, which can be found to the next slide. So let me show the next slide, emphasizing how the original and the new quantity equilibrium is solved. So we already have computed for the original price equilibrium and the original or the new price equilibrium. Now we are to solve for the original quantity equilibrium and the new quantity equilibrium. And we can use the demand equation as our reference in solving for the quantity equilibrium. So to solve for the new quantity equilibrium, of course we have to use the new demand equation. And to solve for the original quantity equilibrium, we are to use the new demand equation as our original demand equation as our reference. Again, if we are to solve for the original quantity equilibrium, we have to use the new, or the rather original quantity equilibrium as our reference. So the original quantity equilibrium is given by 72.5 minus 12.5 P. And substituting the original price equilibrium to the P of the original demand equation, we now have 72.5 minus 12.5 P times 3.54. And simplifying, we will now have 72.5 minus 44.25, which is the value of our QD, which is eventually the value of quantity equilibrium after we have substituted the price equilibrium. So the quantity equilibrium now is 28.25 units, and this serves as the original quantity equilibrium because what we have used is the original demand equation as a reference. Now for the new quantity equilibrium, as I have mentioned earlier, we will use the new demand equation as our reference. So we have the new demand equation of 50 minus 12.5 P, and substituting the new price equilibrium of 2.73 to the P of this new demand equation, we now have QD is equal to 50 minus 12.5 P times 2.73. And simplifying, we can arrive at this value of new quantity equilibrium equal to 15.88 units. So this is how we derive the value of the original quantity equilibrium and the original or the new quantity equilibrium. Okay, again, the original quantity equilibrium and the new quantity equilibrium. The original quantity equilibrium is 28.25 units and the new quantity equilibrium is 15.88 units. So what happened? Because of the decrease in demand, quantity equilibrium also decreased. So a decrease in demand causes a decrease in quantity equilibrium. Because of the decrease in demand by 22.5 units, quantity equilibrium also decreased from 28.25 units to 15.88 units. So how much is the change in quantity equilibrium? The change in quantity equilibrium can be computed by subtracting the original quantity equilibrium from the new quantity equilibrium. So change in quantity equilibrium now is equal to QE sub 2 minus QE sub 1, which is equal to 15.88 minus 28.15. So what would likely be the value of the change in quantity equilibrium? You can solve it yourself. So 15.88 minus 28.25. How much is that? Now let us go to the next slide. decrease in demand causes a decrease in quantity equilibrium, and the decrease in demand causes a decrease in price equilibrium. So this is just a summary of what we have presented in the earlier slides. So again, decrease in demand causes a decrease in quantity equilibrium, and decrease in demand causes a decrease in price equilibrium. Okay, so let us now move on to this next slide. And the next slide is emphasizing the change in supply while the demand is constant. So graphically speaking, there is no shift in the demand curve. What can be found is only a shift in the supply curve. The shift in the supply curve is directed to the right, which means that there is an increase in supply. So let us begin from this problem statement. The original demand and supply equations are QD equal to 72.5 minus 12.23 P, and QS is equal to 25 plus 15 P respectively. Solve for the new price and quantity equilibrium given that an increase in supply by 15 units occurred after a period of time. So just the same as what we have done for the new demand equation and new original demand equation, we can also derive our new supply equation by using our original supply equation and adding from it the amount of change in supply. So the amount of change in supply is 15 units. Okay, so the new supply equation now is equal to the original supply equation plus change in supply. And the new supply equation is minus 25 plus 15P, so that the new supply equation is given now by negative 25 plus 15P plus an increase in supply by 15, so plus 15. And so the new supply curve now is negative 10 plus 15P. So we have now the graph for the original supply equation given by negative 25 plus 15P, and the new supply equation given by QSRT equals negative 10 plus 15P, where the original demand curve and the new demand curve are the same because there is no shift and assumed constant, so that QD1 is equal to QD2, which is 72.5 minus 12.5P. So our task now is to solve for the original price equilibrium and new price equilibrium first. So the original price equilibrium can be solved by equating the original quantity supply equation and quantity demand equation. So negative 25 plus 15P is equal to 72.5 minus 12.5P. And solving for P, we can now have this value of 3.54 as our original price equilibrium. And what about for the new price equilibrium? We will be equating the new supply equation to the new demand equation. But the new demand equation is the same as the original demand equation, because again, this the demand is constant. So we now have QS2 equal to QD2, which is minus 10P plus 15P equals 72.5 minus 12.5P. And solving for P, we can now have a value of 3.18 pesos as the new price equilibrium. Let us now move on to the next slide. And the next slide will only compute for quantity equilibrium based from the original or the previous slide, given the same equations for demand and supply emphasized in the last slide. So solving for the quantity equilibrium now, we have to equate, of course, or to use the original demand equation. And the original demand equation is given by 72.5 minus 12.5P. If we substitute the original price equilibrium to this to the P of the original demand equation, we can derive the quantity value, which is 28.25, and this quantity value 28.25 will serve as our original quantity equilibrium. Now, what about solving for the new quantity equilibrium? The new quantity equilibrium can again be solved by using the new demand equation and substituting from the P of the new demand equation the price equilibrium of 3.18. So we now have Q equal to 72.5 minus 12.5 times 3.18. And so we now have 72.5 minus 39.75, which will result to a value of 32.75. So 32.75 is our new quantity equilibrium. So you notice that because of an increase in supply, because of the increase in supply, the the quantity equilibrium also has increased. So how much is the increase in quantity equilibrium? The increase in quantity equilibrium, or the change in quantity equilibrium, is simply solved by subtracting the original quantity equilibrium to the new quantity equilibrium. So change in quantity equilibrium is QE2 minus QE1, and QE2 is 32.75 while QE1 is 28.75. So how much is the new quantity equilibrium? About 4.25 units. So that's the value of the change in quantity equilibrium. Because of the increase in supply by 15 units, quantity equilibrium increased by 4.50 units. 4.50 units. Yes. So take note of the original and new equilibrium points. The original equilibrium point is between QD1 and QS1, and the new equilibrium point is between QD2 and QS2. It so happened that QD1 is the same as QD2. So to summarize, increase in supply causes an increase in quantity equilibrium, or an increase in supply causes a decrease in price equilibrium. If we look at the value price equilibrium, how much is the change in price equilibrium? The new price equilibrium is 3.18, and the original price equilibrium is 3.54. 3.18 minus 3.54 is a decrease in price equilibrium. Okay, so please take note of this relationship. So again, because of the increase in supply, price equilibrium decreases. Now, so in the previous slide, what we have illustrated is increase in supply. This time we will illustrate the decrease in supply. And speaking about decrease in supply, of course, the supply curve shifts to the left. Okay, but let us begin our analysis from this particular problem statement. The original demand and supply equations are QD equal to 72.5 minus 12.8 P and QS is equal to minus 25 plus 15.5 P respectively. Solve for the new price and quantity equilibrium given that a decrease in supply by 10 units occurred after a time period. So a decrease in supply by 10 units occurred after a time period. So what we need to do after reading the problem statement is, of course, to come up with the original supply equation and new supply equation. But the new supply equation is based from the original supply equation plus the change in supply. So the new supply equation is now based from the original supply equation plus the change in supply. And the original supply equation is given by negative 25 plus 15P, while the change in supply is decreased by 10. So we will introduce negative 10. Therefore, the new supply equation is QS1 minus 10, which is negative 25 plus 15P minus 10. So simplifying, we now have QS2 equals negative 35 plus 15P. And now that we have derived the new supply curve, and we now have we already have the original supply curve and original demand curve, we can now solve for the original price equilibrium. And just the same, to solve for the original price equilibrium, we have to equate the original supply equation to the new or to the original demand equation. So negative 25 plus 15P is equal to 72.5 minus 12.5P. By solving the P, in solving rather the P, we can now have this value of 3.54. So 3.54 is the original price equilibrium. Now, what about for the new price equilibrium? The new price equilibrium can be solved through equating the new supply equation to the new demand equation. The new supply equation is negative 35 plus 15P, and the new demand equation is 72.5 minus 12.5P. Note that the original and the new demand equations are the same because there is no change in demand. The demand is assumed constant. So equating now the new supply equation to the new demand equation, we now have this value price equilibrium 3.90. So the 3.90 is the new price equilibrium. So how much is the change in price equilibrium? If we are to solve for the change in price equilibrium, we can just use the formula P E sub 2 minus P E sub 1. Subscript of 2 means new and subscript of 1 means original. So the new price equilibrium minus the original price equilibrium will give us the change in price equilibrium. 3.90 minus 3.54. So that's about how much is the change in price? 90 minus 4, 6, 8. It's about 36. About 36 centavos is the change in price. In short, negative. Yes. No, positive rather. 3.90 minus 3.54 is positive. Positive. Positive 36.36 pesos. 0.36 pesos. So because we have computed for the price equilibrium, we can also compute for the quantity equilibrium. And we can compute the quantity equilibrium by using the original demand equation or finding the original quantity equilibrium. And we can use also the new demand equation for finding the new quantity equilibrium. So substituting the price equilibrium that we have earlier computed, the original price equilibrium, is substituted to the P of the original demand equation, we can solve for the original quantity equilibrium. So QD original is 72.5 minus 12.5 P. And substituting to that P, the value of 3.54, the value of the original price equilibrium, we can have now this original quantity equilibrium equivalent to 28.25. Now what about for the new quantity equilibrium? The new quantity equilibrium can again be solved using the new demand equation, 70.5 minus 12.5 P, and to substitute the new price equilibrium to the P of the new demand equation, we can get to the value of the new quantity equilibrium. So here, the computed value of new quantity equilibrium is 23.75 units. So how much now is the change in quantity equilibrium? The change in quantity equilibrium is QE2 minus QE1. QE2 is 23.75 and QE1 is 28.25. So what happened? Because of the decrease in supply by 10 units, quantity equilibrium also decreased. By how much? The decrease in quantity equilibrium is QE2 minus QE1. So 23.75 minus 28.25 could be the value of the decrease in quantity equilibrium, and you can solve it yourself already. So to summarize, a decrease in supply causes a decrease in quantity equilibrium, and a decrease in supply also causes an increase in price equilibrium. So the price equilibrium increased, quantity equilibrium decreased because of the decrease in supply by how much? By 10.